Hey, hi all. So today we'll be learning on recursion. So what is recursion now? It's similar like when you have some type of repetition code and you want to write a optimized way. Like if till now we are learning like loops, right? So in loops, what we were doing, like there was a bunch of code. To repeat it, you had a certain statement, like let's say for loop or a while. Similarly, now the same thing we are doing it with the help of recursion. That is nothing but with the function. So, in simple words, recursion is nothing but calling a function inside a function itself. Okay. So, that itself will become a loop. Uh, cool. Let's practically do it once. Let me create first main this, and I'll be creating a function, let's say outside of it at top. And here I'll simply call a function. Let's say the function name is static void. It's not going to return anything. I'll just say the function name is display. And cool. So what I'll do inside this function is just say I'll simply print south hi. Okay. So what I've done, I've simply printed hi. And in case if I call this function inside here itself, so if I write display, this is a recursion. So where we usually call it, we usually call this function till now, like let me cut it, and we usually call it in main function. Like this is where our program will start to run, right? So we used to call it here. But if we call it here, what will happen? It will be called once and then it will just log this thing. And in case if I call it here, so from here, it again goes to this line, then executes this, again this. So it's in a loop. So let's try to see what's the output of this. So if I run it, you should be able to see an infinite loop, which is saying hi, continuously. And at the moment, it will give an error, or it will simply say that recursion, like it has exceeded some limit. Okay, so why is it has exceeded? Because if you see here, what is happening, it's continuously in loop. So if when it comes to this line, it again calls this, then it prints this, then it comes here. Again, the same thing is in continuous loop, right? So you can consider something similar to while loop. So to avoid such scenarios, like every recursion thing, we require one thing, that is a base condition. Okay. Now, what is the base condition? So let's say whenever you start from a point, you know at a certain point, your function is going to end. And that particular condition where you know that this is where my function is going to end, like this is the last, like it can be related to arguments. Like if this particular argument comes, then return this function, stop this function. In that case, you can say, like this is the endpoint, and this can be a if condition, or a few times even without providing certain condition, you can do it. So let's practically do it once. So let's try to print the numbers from 1 to 10. Okay, let's have this. Let me change this display like 1 to 10. Okay, then. So what I have to do? So first of all, I know going forward, we'll see like what is actually a recursive mindset, because here the mindset of recursion is bit different till now. The approach is bit different, that you have to think about the end goal. Like let's say if n is your n, then you have to just make sure that if the function is working for this, then you have to also make sure that the function for this is being worked. And once these two approach are done, and a final base condition. So if you clarify 1, 2, and 3 steps, then done. All the recursion problems are going to work fine. But let's not get into this right now. Let's try slowly, and let's try to print the numbers from 1 to 10. And in this, we get to know that at certain point, when it's a 10, we want to stop our function. So obviously, what is our base condition? That if the number is 10, stop it. So let's say we are going to get an argument as num. And here I am simply going, I have to also mention what it is. It is int And here, after this line, I am simply going to say if in case my num is equal to 10, okay, then what I'll say? I'll say return. Oh, this is Java. So I have to use curly brackets and I have to simply return. Just say 10. Okay. Oh, okay. This is actually void. So what I'll do instead of returning, I'll write here south. And inside this, I'm going to say 10 and close this, go to next line. And here I'll type return. So this is the point where our code will end. Okay, good. Now, here what I have to do is I have to say whatever number they have given. So I have to just say num plus 1. So here in case if they have given me 1, let's say first copy the function name, Control C, Control V. I'm initially passing it, let's say 1. Then let's run and check first it works or not. Cool. It didn't work. So what happened? It went to 2. Yeah, and we didn't call the function itself. So I have to call this function inside it. So this step we missed it. And whatever the number is there, I have to just increase it by 1. And later, once it comes to this point, it is again going to call this part. It will check the condition. Then again, it will just print it. Whatever it is here, in fact, it's just num and not plus 1, display 1 to 10. Okay, let's check this. Cool. We are starting with 1 and ending up to 10. Yeah. Okay, works fine. Now what I want is if any number is provided to us, we will go from that number to 0. Okay. So let's say if we want to go to 0, then obviously I get to know that first thing, what is my base condition? That base condition, if it is 0, I have to return. Okay. So let's do this. So here I'll simply say void. Yes, let's do it. Void itself. Void. What is this? Descending. Do we require an argument? Yes, we require an argument now. Cool. And we have to say if num is equal to 0, then what I'll do is I'll return. I'll just simply say return. And before that, I'll simply say solve. What I have to solve? Let's say num. Clear? So from this, one thing is clear that if it is if it reaches 0, then we are simply displaying the 0 and we are going to return from that. In case if condition is not true, then I'm again going to call this function, let's say descending num. But here what I have to make sure now, here 100 is passed. So for 100, what it will display? Let's say it is displaying south num. So for 100 it is working. What if I call 99? Even for 99 it is working, right? So here itself I am calling 99. How? I am simply saying -1. So in this way the loop is repeated here. I have to simply call this function now here. So let's say copy this, paste it here, and let's pass 100. So we started with 100 and we are able to reach up to 0. Clear? So I hope till now at least there is no confusion that how recursion works. So it's simply calling a function inside a function. Here we are calling this function and it's being repeated. Okay. Okay, sounds great. So this is how recursion works. Nothing but calling a function inside a function. Okay. But there are few things like there is a particular mindset to solve recursion problems. Okay. The first thing is that still now, whenever we used to coding, we always used to think from starting point. Like, let's say if we are also writing a loop to print 100 numbers, we always started from 0, then we go up to 100. In recursion, it's usually different. We here try to think about the last term, and we just want to make sure that it is working for that last term as well as 1 minus it. Okay, like there was a best, like when I was learning it, I had watched a YouTube video which represented in much visual way. Okay, if I tried to find it just to link it here, but I was not able to get it. So like, see, recursion is a simple, it's just this thing, but actually having the recursion mindset is bit different, like difficult thing. We'll try to see that. We'll try to solve the recursion problem itself in two ways, like one in a wrong way, wrong approach, and the second in the correct approach. Okay. So for right now, what we'll be doing is trying to write a function in recursion, which will give us a Fibonacci sequence value. For example, what is Fibonacci sequence? We have 1, 1, combination of this is 2. 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, and so on. Okay. What should our function do? Let's say, first of all, let's name it 0, 1, 2, 3, 4, 5, 6, 7. Okay. So, yeah, what our function should do? If we pass 7, it should give us 21. This is the work of our function. And we should use recursion. Okay, sounds great. First of all, what will be the base condition? Yeah. Okay. Most probably, the first thing that will be pop up, like here we can see the index. So the first thing that will be pop up is that if our num is 7, so whatever they have entered, if that is the thing, then that will be the base condition. That is the first thing. We can say that 7 is our end goal or the number or the argument what we get. But here is the trap, or we can say a mindset you are using of for loop. Okay, because in for loop, what we think, we start from basic, so like starting. But in recursion, we think of directly endpoint, and we go in reverse order. Okay, so let's put a star mark for this, and let's, while writing if condition, we'll try to see what's the actual this. Then second thing, how will you solve this? So in recursion, like always try to think it as a black box for starting purpose. Let's say draw a box like this. It's always helpful. This is how I learn. And what is the argument you are going to pass? Let's say you are going to pass 0. Or initially, let's say final thing we are going to pass it as 7. And it should give us what? 21. Okay, cool. Sounds good. Let's try to break this down. So if I'll create the same functions multiple times here. So these are the same functions. So if I call this 0, it should return me 1. If I call this 1, it should return me still 1. 2 should return me 2. 3 should return me 3. Then I have again a function which if I passed 4, it should return me 5. Then 8 should return, sorry, this is what? 5. 5, if I pass 5, it should return me what? 8. If I pass 6, it should return me 13. And if I pass 7, it should return 21. For solving any recursion problem, you have to first find out what's the relation. So first of all, here at least you know we are adding the two numbers, but how would you connect it inside a function? So here, if you try to see, like here 7, 21. Okay, so how did we get here 25? So this is nothing but 8 plus 13, right? So any function that gives us 8, then it gives us 13. If we try to sum this up, this will give us 21. So what are these functions? These functions are the ones that have returned here, right? So if I pass 5, it will give me 8. And if I pass 6, it will give me 13. And if I just pass this, like plus it, it will give me 20. Clear? Okay, sounds good. So we are done with what relation thing, like what is our relation here? Okay, let's try to do it once. Here, as it is a static void, what is this fit? Then we are going to get a num as argument. Hold on. And I have to mention what is my num. I'll say it is int. Okay, cool. How would you write this condition? See, writing directly here like equal to 7, it's not a for loop, like saying like you are starting from here. You are actually starting from here. How? Because that is what the argument you are getting. So from here, you are going back in this direction. And if you are going back here, you somewhere know that 0 and 1 is going to give you what? 1. So what can you write the condition here? You can simply mention that if my num is less than or equal to 1, let me write it in this. Okay, if this happens, what you do, return 1. I'll just change this above thing to int, because we are going to get an empty value. Okay, sounds good. So if it is less than or equal to, that means our base condition is done. Now, how would I solve this logic thing? It's nothing. Like I'm simply going to say my fifth, I'm going to return here. Return what? Fifth. Whatever is my num, minus 1. Num minus 1. Plus whatever is my fifth, num minus 2. Cool. Yep. Okay, so that's it. That's the recursive function. Let's try to check it. Let me call this function fib, and let me pass 7, and let me run it. Okay, I have to print it. Back. Brackets. This out. Delete. Okay, run. Okay, cool. You will see 21 is displayed. What will be the 8th one? So 21 plus 13, it will be like 34. Let's see. The answer is 34. Plus 8. And if I run it, cool. So we are getting the output as 34. Okay, clear. But how did it work? So to answer that, like most of the time, so while solving recursion, okay, let me tell you some general steps while solving recursion. First and foremost, always assume your function is going to work. Okay, first step is always assume your function will work. It is going to give whatever argument you pass, it is going to give its answer. Okay, this is the first thing you have to assume. Second thing, you have to make sure your base condition is the correct. Okay, base condition is right. Third thing is always you have to find the relation between the end, like the last term, and just minus 1 and minus 1. So if you are able to do these 3 steps, then that itself is, you are able to solve the recursion. You did not go into depth like how it's working, how it's happening, but still we'll try to explore this particular problem, like how internally, how it's working. Clear? So let's try to break this problem. So here, from here, what you said, you passed 8. So for here, 8 has been passed. And first, the condition has been checked. So 8 is not been, 8 doesn't meet this condition. 8 is greater than 1. So return what? Return fib num minus 1. So here again, one function is called. This is what? Fib num minus 1 is what? 7. So a function for 7 is called. And plus here what is called? A fib function for 6 is called. Okay, cool. Once this fib 7 is called, again it goes up. Let's say now fib 7 doesn't meet this condition. Then from 7, what it says, it is again calling for 2 function here. So this particular thing is calling again 2 thing. So here fib -1 will call 6, and here -2 is going to call fib what is this, 5. Okay, great. From this again there are 2 things, like let's say Fibonacci sequence for 6 is being called. So again you go up like Fibonacci 6, right? So 6 is called, so 6 condition doesn't match here. Then 6 -1, then again you come to this line, you do 6 -1, you call a function here. Fib 6 -1 is what? 5. Then fib 6 -2 is what? 4. Okay, good. Again, this thing happens, same thing. So if you see, it keeps on repeating. So fib, here it will be for 4. Here it will be for what? Fib. What's this? 3. And this I'll try to break it again. This 4 will be for 2. Let me put it like this. Sorry, this will be for 3, and this will be for 2. Let me just close this. And again, this 3 is being called for 2. Okay, and this 2 is being called for what? So 0 or like 1 and 0. Clear? So this is the one tree that I have bricked. Okay, cool. So whatever I have done here, 2, 1, 0 here, the same thing is going to come here. So here, let me draw the same box, and this is going to give me what? 1 and 0. Like these are the 2 things that is being called. So if you see, these are again repetitive thing here. You can just draw a graph like this and try to come up with the solution like this. But if we try to see the answer, so here what is happening? This, when it reaches this is the point where we are actually getting the value, that is 1. So to get any value, you have to go up to this last element. So here 1. So from this 1, it's being passed again back. So from this 1, it is being passed again back. So here what is happening? 1 plus 1. This is actually the answer. 2 is coming here. From here 2, this value is being passed. And here what it is? We have 1. So from this 1 is what? We have given the condition that it should return 1. Then the 1 goes here. So 2 plus 1. This is 3. Okay. And for 2, what it is going to return? We already saw. For 2, 2 is going to return. So here it is 2. 3 plus 2 is what? 4, 5. So this is being passed where? Like this. And this is here. So for Fibonacci 4, the answer is 5. What is the answer for Fibonacci 3? We got it here. That is 3. So again, you can draw the graph, but you are going to get the answer as 3. Okay. So what is the Fibonacci 5? 5 plus 6, 7, 8. So this is going to be passed here. This is going to pass here. So this will be 8. Okay. We come with Fibonacci 4. So Fibonacci 4, we got the value here, 5. So this is 5. So Fibonacci 6 is nothing but combination adding these 2. So 8 plus 5, we know it is 13. Okay. Fibonacci 5, what will be the value? We got it from here that it will be 8. If you draw the tree, you will get it all. But we saw that Fibonacci 5 is giving us 8. So 8. 8 plus 13 will give us what? What it will give? 21. Okay. So for Fibonacci, what we are searching for? 8, right? Okay. So for Fibonacci sequence 7, 6, we got the value as 13 here. So I'm going to write the 13 here itself. So 21 plus 13 is going to return us what? 34. Clear? Okay. So general rule of thumb here is like never fall into like how this is working, like never go into that. Like just you have to find out the relation between like the last and the last second term. The second thing is like having a proper base condition. And that's it. Like if you have solved these 2-3 steps, then that's it with the recursion. So let's try to solve few more problems. Here we'll try to solve the factorial one. Now again, if you see what is factorial? Any number, like let's say if you take 3, factorial of 3 is nothing but 3 into 2 into 1. Factorial of 4 is nothing but 4 into 3 into 2 into 1. Factorial of 5 is nothing but 5 into 4 into 3 into 2 into 1. Clear? Okay. So let's draw a black box that we don't know. So this is a box. We are not sure how this internal thing will work. But what we want, if we pass this 5, okay, we are going to pass this 5. What it should return? It should return the answer. What is the answer for this? 5 fours are 20. 20 into 3 is how much? 60. 60 into 2 is 120. Clear? Okay, let's not calculate for like 120. Okay, if we pass 5, this will give us answer as 120. This is our goal. Okay, so first thing is let's try to find out the relation. Now, if I pass 4, what it should give me? 4 3s are 12, 12 2s are 24. So this should give me 24. Okay, got it. Now, to get this 120, like let's say again, I'll draw the previous thing how I was doing, like 1, 2, 3, 4, 5. So to get up to 120, by passing 5, 4, here it is 24, 3, 2, 1. So 1, this, then 1 into 2 is nothing but 2, 3 factorial is nothing but 6. Okay, cool. So what's the relationship? So to get 2, what I have to do? For this function, I have to multiply it with this 2. Then I'll get 2. Okay. To get 24, what I have to do? Its previous function, the nth term, into 4. Previously, here we are doing entire thing, but I need not do entire thing. Here, what I have to do, I have to just do 6, multiply by whatever is the number. If you want to get 6, it is nothing but this entire function into this 3 thing. Similarly, if you want 5th one, you have to take this entire function, which will give you the answer, and that answer, you have to multiply it with your particular number. Cool. So we just found out our relation thing. Okay. So relation is done. What about base condition? Are you again going to say 5? Like from starting from here to here? No, we are always starting like 5 will be given to us. So we are going in reverse order. So somewhere we will reach here. And we know for 0, at least the output is 0. And if we try to multiply anything, everything will be 0. So we are not going to consider this. We are simply going to say if we reach 1, return us what? 1. Clear? Okay. And obviously, if it returns 1, here if we do 1 into 2, it will obviously be 2. So this thing is sorted. So let's try to build this one. What it is? Static void. No, not void. We are going to return, right? So int, what is this? Factorial. Int number we are going to get. Okay, cool. Let's write base condition. Base condition is what? If my num is equal to 1, if this happens, what I have to do? I have to return 1. Okay, sounds good. What next? Then return. What I have to return? This entire factorial thing function with -1. That is num -1. Okay. Into what? Whatever is the num. Yeah, and done. So let's check if this works. Control C and Control V. Let's pass 5 as this, and let's see if 120 is the correct answer. And if you see 120 is the correct answer. In case if I pass 4, should return me 24. And if you see, it works perfectly fine. Look. Okay, sounds good. Let's move with the next question. Where we want to solve sum of natural numbers. So in case if we give 7, we want 1, 1 plus 2 plus 3 plus so on up to 7. So summation of this is the what we want. Okay. So again, what will be the relationship? We want a function 7. If we pass it, its answer should be given to us. Okay, fine. Then let's break this problem now. So let's say these are some particular parts. Let me write 1, 2, 3, 4, 5, 6, 7. If I give 7, it should give me its answer, summation. To get this answer, what I want, whatever is the summation up to this, like 6 summation, like whatever is the 6th answer, plus 1 if I plus the number I do, then that itself will give me the summation of this. So similar to factorial itself. So let's try to just copy paste it and see if it works fine. Down. Okay, and let me enter, let's say and let's say num equal to 1. Okay, return 1. When it is -1, here we have to do like addition, should be plus. Then what else? Yeah, we have to change this function name, Control C, Control V, Control V, and we want to check for this is 7. What is the answer for 7? Cool. The answer is 28. How can we confirm if it is correct? Let's check for 6 and just add 1. Let's do it for 6 and then add 7 to it. Okay, 21. 21 plus 7 is nothing but 28. So we can confirm our summation recursion is also correct. Clear? So I hope, like, if you see why recursion is that important, because just with simple, like hardly few lines of code, we are able to perform complex problems. And going forward, when we'll be learning graphs and all those things, recursion is must in that. Clear? So let's try to solve few more questions. So in next problem, what we have to do is, let's say we have an array. We have to figure out if the number given in this are sorted. Clear? Okay. If it was a loop, it would be easy. Like if you could have just started from first point, went up to the last point, and you kept on checking what? If the upcoming number is greater. Okay, cool. How would you solve it with recursion? So here, again, we have to build the relationship. So if we have to just make sure whatever the number is given, let's say like the array is given, the array will be given for us. Yeah, we can break this problem in this way. Like, let's say no matter whichever array you give me, what I'll do, like let's say I have one more array and this is 8, 9, 10, 11. The function of my array, like the function, the work of my function is to just compare last 2 elements or first 2 elements. You can pick anyone. I'll stick with last one. So I'll just compare. If you pass me this function, what I'll check is that this should be less than this. Okay, so let's say you pass me the array. Okay, what I'll check, I'll simply check if the last element is like greater than, or I've written it because let me write it like this. So if the last element is greater than last minus 1, that is nothing but last minus 1 is this, last minus 1. Okay, if this is correct, then pass me as true, else pass me as false. If not, pass me as false. Okay, so this is how I broke my problem. Now, what I have to simply do is I have to keep on passing the array in shorter version. So first what I'll pass this entire array so that it will compare between 5 and 6. Then what I'll do is I'll pass the array from 1, 2, 3, 4, 5. So it will just compare 4 and 5. Then I'll break this array and I'll pass only this much. Then I'll again break this array and I'll pass only 1, 2, 3. In this way, the array is getting shorter and shorter. So my base condition should be in such a way that, should I write it? Oh, yeah. Okay. If you are giving particularly, yeah, you can give the base condition for just 1, saying that if length of array is 1, then you can say, you can return it basically true. Or if it is greater than 2, if the length is greater than 2, you have to simply check like which, if this is greater, then you have to pass it. Did I make sense? Yeah. So what is the relation? The relation is nothing but checking this thing. What is the base condition? Base condition is making like if the length is 1, what you are going to return? You are going to return true. Okay. That's it. Let's try to code it. Static. Right. Static. Okay. Boolean. Okay. What's the function name? Sorted array. Sorted array. Okay. What it is going to take? It is going to take an argument square brackets array. Okay. As well as we will try to pass a length of it. So we did not, even you can do it without passing the length by just cutting it, but that will not be great. Well, let's pass the length also. So int length, okay, and curly brackets and now what is the base condition? If my length is equal to, or I can simply say is less than, if my length is less than 1, what you have to do? No, I don't want. I'll just leave it as equal to. Okay, then what I'll do is I'll return. Okay, this is what it is going to return. Then else what I have to do? I have to do a bit of check here. Here I have to check. Now what is my condition here? If array of length is greater than array of length minus 1. Yeah. Just make sure when you are passing the length, you are not passing the actual length, you are passing -1 because you have to take a note of index. Okay. So just take care of the index here. So if it is greater, then what I'll say, I'll return true. Okay. Yeah. But instead of passing here true, what I'll do is I'll pass the same function because if it is true, then keep on checking if the rest is also true. So sorted array. And let's pass the array and comma. Len will be what? It will be reduced by 1. Len. Okay, -1. Okay. Else, what we'll do? Else return false. Okay, sounds good to me. Why there is an error? Okay, here should be capital A, same as here. Okay, cool. Let's test it. So sorted array. So Control Z, Control C, Control V, and here I have to pass the argument. So in square brackets array curly brackets 1, 2, 3, 4, 5, 6. 6 and here I'll simply pass array, comma, make sure you are passing the correct index, that is 6 minus 1, and let's run it. I forgot to put a colon, semicolon, and let's run it. You see, it's returning true. What if I return at 4 here, 4 comma this? It's going to return me false. Yep. Got it? Okay, cool. So let's move with the next problem.